Hey, what's up guys, my name is Cherno, welcome back to my game engine series. So last time we talked about UUIDs and introduced them into the engine. Check out that video if you haven't already. And today, now that we've got UUIDs, let's talk about how we can actually hit play and set off our scene runtime. Because so far what we've been doing is simulating an existing scene, whereas we know that in reality what we probably want to do is basically load up the scene that we've been editing in like a runtime state. So what does that even mean and how does that work? Okay, well let's jump into what we've got so far. So we've got this basic setup that we established, I think last episode or maybe during the Box 2D kind of physics episodes. This is what we have. If we hit play, it'll jump to whatever the game camera kind of is. And then obviously we will see this kind of physics simulation taking place, right? That's all good, but as soon as we hit stop, obviously we don't reset anything. It would be ideal for you to reset everything, right? And that's probably another thing we should do is not display the gizmo, or at least display the gizmo in the correct location when we hit play using this camera instead. But anyway, the point being that you can see that we obviously don't reset anything. When we hit stop, everything just remains exactly as it was, because all we're doing when we hit play is rendering from a different point of view and then running the physics simulation, which allows us to modify our transform component data. That's all that is actually happening here, which is not good for a number of reasons, or on a number of levels really. Because the thing is, if you think about the issue, at the moment, yes, it might be true that all we really need to do is just like remember the transforms of these objects or of any physics object, and then just reset it when we hit stop, right? But that's not really sustainable, and it's also not going to scale well, because at the end of the day, there are a lot of things that can happen during a scene, right? I mean, if you think about involving a script runtime, I mean, just think of a game made in like Unity or something like that, right? We could have a script which spawns the entire level procedurally, does all of this stuff, right? Sets up prefabs, spawns them into the world, runs physics simulations, runs other code that generates like assets, like textures even. The amount of work that we can do once a game starts is, I mean, it's honestly infinitely large, right? Like we could do literally anything, especially once we have like a script runtime. So what we kind of want to do with this scene is not necessarily reset it. What we want to do is actually create an entirely new scene based on whatever this editor scene is, right? So that we have physics 2D. This is our current scene, right? When I hit play, I want to be able to basically load this scene in kind of a runtime fashion, I guess, establish the Box 2D world and anything else that needs to be kind of present for a real scene. But then run that scene instead. And then when I hit stop, I can just delete that scene, release it, and then basically change the scene that is at play here in the editor to be that original editor scene that we were editing, right? So in summary, I mean, again, long story short, if you actually think about what needs to happen here, we just need to copy whatever scene is currently being displayed here. We just need to copy this scene into a new scene, which we can call runtime scene, and then basically switch the editor to now be to use that runtime scene as the context for literally everything, right? But then when we hit stop, switch that context back to whatever the scene was that we were editing. So how are we going to do that? One other thing I want to quickly point out before we go there, someone I think pointed out a bug where if you are playing and then you try and load a scene, it will just crash. So we should probably fix that before we get into this. But other than that, that's kind of the plan for today, just to make that kind of copying behavior work. So if we go over here, so open scene, I guess we just won't let scenes be opened if we're running, or rather we'll stop the scene first because we still want to load the scene probably. So if we do open scene, if the current scene state equals, let's just say if it doesn't equal edit, right? Then we're just going to run stop scene, or scene stop, on scene stop, right? So that should fix that bug. Let's take a look at that, make sure that works. All right, scenes, physics 2D, I'll hit play and I'll drag it in again. Okay, so you can see it just stops it, which is kind of what you would expect. Okay, great. I mean, we could bring up a dialogue being like, hey, are you sure you're doing this? Maybe your hand just had a spasm and you accidentally dragged that in. I don't know, but we'll leave it like this for now. So that's that bug fixed. Okay, so copying scenes and all of its architecture, how is this going to work? So of course, this was kind of discussed and I did implement this in the last live stream, right? So I'll kind of be using the code that's already actually present in the dev branch, not to be confused with Hazel Dev. It's not Hazel Dev, this is just the dev branch on the GitHub. repository, right? There'll be a link in the description below. So you can obviously kind of see the code that's already been written as part of the live streams that happen on twitch.tv/the Cherno. But anyway, getting into it. So the thing that really needs to happen here is we obviously need to basically have some kind of runtime version of this scene. Now we have a scene called active scene, and this is fine. But what I'm going to do is I'll leave active scene like it is, but then I'm going to explicitly set up two different scenes, an editor scene and a runtime scene. Right? Now, you don't technically need to retain three kind of scene refs or three pointers here, because I mean, at the end of the day, there's really only two scenes. There's the editor scene and the one that we're currently running. I've written it like this with three actual scenes just so that it's a little bit more verbose and will make hopefully more sense. So in the beginning, what happens is, well, not in the beginning, but when we open a scene, what we want to do is basically, instead of setting the active scene to be this new scene that we're loading over here, we want to specifically, if the deserialization worked out, I want to set the editor scene to be this new scene, right? That's kind of what's going on here instead. And then we can do all of this resize stuff. But then what I'll do is kind of when that's all done, and maybe based on some other states, I'm going to actually set this to be the editor scene. So the active scene and the editor scene are actually kind of equal. I mean, they're two different references here. They're two different shared pointers, but obviously the object itself is the same. So this is what happens when we deserialize a scene. We load it into the editor scene, and then we set that to be active. Now, when we hit play, though, we don't want to just do on runtime start. What I want to do here is I actually want to set the runtime scene to be some kind of like, I don't know, maybe we'll make a function called copy. Well, the way this works in Hazel Dev, it's actually called copy to, and then you can give it a target scene to copy into. But I'm actually just going to make a scene copy function, and it's going to return a new scene for us, right? And then, so we'll create that runtime scene, and then what we can do is, well, we can call on runtime start, and then we can set the active scene to be the runtime scene, right? And then all we have to do over here is make sure that we obviously call runtime stop over here. And again, whether or not you do this on the active scene or on the runtime scene, they should be equal. So it's not really a big deal. But the point is we're going to change the active scene to the editor scene. Now, by doing so, right, by doing so, the runtime scene here, obviously, like if we keep track of all of these reference counts in our mind, the editor scene is always going to be parked here, right? And I'm beginning to think that maybe this is even kind of overcomplicating it. So, well, but I do think that the distinction between the names is good. I don't know, because, and you're about to see why I'm saying this in a minute, but what we're doing here is the editor scene will permanently be parked in the editor scene shared pointer, right? So that will always kind of exist in memory. But here, if we do the same thing with the runtime scene, that's obviously not something I want to do, because once a runtime scene gets stopped, we can basically delete it, right? And the simplest way to do that is probably to just set runtime scene equal to the null pointer. So what this will do is reassign runtime scene to be something else, right? Which will mean that the reference count will be decremented. And it doesn't matter really where you do this. Like we could do runtime scene on runtime stop, right? Runtime scene equals null pointer, then active scene equals editor scene. But the point is, as soon as nothing obviously has that runtime scene anymore, then the reference count will fall to 0, and we will completely delete that object from memory. So the idea is when we hit stop, obviously, since nothing else is holding a reference to the runtime scene, it will in fact be destroyed. Yeah, but it's important, I guess, not to, and you can probably tell here that there's no need for this runtime scene, right? Because active scene is runtime scene, and it only exists for that lifetime. But I've just written it this way so that it's a little bit more kind of aware. But again, I'm doubting myself as I'm recording this episode, because I don't know, maybe it just makes sense to have an active scene and an editor scene. And then obviously what you would do is just basically, well, you wouldn't need this. You just set active scene equals to scene copy active scene or editor scene, right? So we make a new scene out of that. Maybe I'll do it that way. You guys can let me know what you think in the comments below. Didn't really plan this, to be honest, but we could make the active scene copy the editor scene. And that's obviously reassigning active scene to this new scene that we've made, right? Assuming that everything goes okay, which it should. And then we just do active scene stop, active scene null pointer, or rather we don't even have to do that. We just set active scene to editor scene. And since active scene is the only thing that ever held on to this kind of new scene that we've made, it will then get destroyed. So it's a little bit cleaner this way, but it might be a little bit harder to understand because active scene, anyway, whatever. So the thing with active scene is that everything else kind of works with this design, right? Like you can see that basically like, we still have active scene on update, active scene on render, wherever that happens, or on update, sorry, does the rendering, active scene on viewport resize, you know what I mean? Like we've just changed the active scene to be this new scene. So everything else will work. We don't need to do any kind of like, if it's a runtime, update the runtime scene. No, it's all kind of going to be inside active scene. And of course that would have worked if I had the runtime scene pointer as well. It doesn't matter. Anyway, so scene copy editor scene, this is kind of the meat of it, right? So how are we going to write this function? Well, the hardest part of copying a scene is copying the ent registry, right? Because it doesn't really have a good copy function or a clone function. I think it used to, but it's been removed, and I think they're planning to add it back. Because this isn't really traditionally, like, it's not really traditionally a behavior that the entity component system should really support. I mean, it definitely should because there's so many reasons to, right? But in terms of the scope of an actual ECS, you don't really copy an ECS usually, right? It's kind of the meta programming that you do around the ECS that would require you to copy it. Within the ECS itself, there's no reason to. Your registry kind of just exists with all these entities. You don't really copy it, right? But for this purpose, we obviously need to copy all of the entities, all of the components that are inside here. And remember, it's really just, the registry is really just component data. And then we have entities, which are identifiers into certain kind of components, right? So that we're aware that like our camera has a camera component and a transform component with these values. So the components are really what we are trying to copy, but we also need to somehow retain the entities so that we know which components belong to which entity, right? Because that's equally as important as just having the physical component data there. But anyway, so what we'll do is, I guess maybe I'll do it up here. Static ref scene copy. Right, and then this will take in just another scene that we are going to copy. I don't know, maybe I should do this at the bottom. I like putting static stuff at the bottom, but if it's to do with construction, I generally put it here. So let's create this. Okay, cool. Get rid of all of this extra fluff. So ultimately, like the point here, obviously, is just to create one of these scenes. So I'll call this new scene, right? And this will just be create ref scene. Now, if we look at what a scene actually is, I mean, it's the registry, but then it's also just a viewport with height and a null pointer kind of box 2D world, which really is only needed for the runtime scene. So viewport width and height, I don't know if we need to copy that. The reason I'm saying that is because if we look at editor layer, I think it just sets the viewport like every frame maybe. So set viewport size, editor camera, active scene on viewport resize. Well, no, actually, it gets the viewport size from the frame buffer, specification. Okay, I think what it probably should do here, because we don't have a scene renderer yet. That's right. Yeah, okay. I guess we probably should do that, just because obviously I don't think the frame buffer is going to change, and then therefore we won't have the correct values in this new scene. So what we'll do actually is as the first kind of step over here is we'll just copy those values, right? So new scene, and by the way, I could use a copy constructor, I'm aware. I just wanted to kind of make this return a ref specifically and be a little bit more kind of explicit as to like, you want to copy this. So that it's not like an accidental copy. So we'll do new scene viewport width equals viewport, height is obviously what I wanted. And then we'll do height, and sorry, M is, this is static, right? So we need the other scene as well. So other is like the source, that's like the destination. I could kind of rename them the source and dest, but I guess we'll keep it like this to be deliberately hard, right? Okay, so the way this is gonna work is there's basically two stages to this. We need to copy the entity identifiers, right? Which means we need to create entities in this new scene, but then we also need to patch up their components and copy the components. And it would be good to try and kind of do this obviously as efficiently as possible. So what I'm actually going to do, and the other really important thing, right, is that we can't simply just create entities. We actually need to make sure that we use this new function we wrote last time to retain the identifiers of the entities, because obviously those IDs are going to be used for a lot of things, and they need to match, right? If another entity is like a child of some other entity, which I know we don't support yet, but we will, right? Then obviously it needs to know what its parent is. If it like some entity references another entity, again, it's probably going to do that internally via the UUID. So therefore it needs to actually match, right? You can't just create this whole new scene with completely different identifiers, because then nothing will, like the relation between objects and between entities will be lost. So we need to specifically do this, right? So the way we're going to do that is basically we're going to just look into every entity that we have. And the best way I think to do that is basically to just establish this kind of, okay, well, the first thing I might do is pull out the registry. So we'll say, we'll call this like source scene registry. And this will just be source scene being other. So other M registry, right? This is just a little alias just to make it a bit easier. And then this will be our kind of destination scene registry, which is going to be this new scene. And then out of there, what I'm going to do is actually, I'll call this ID view. We're just going to basically ask the source scene registry where we're copying from to set up a view with ID component, right? Because what this is going to do is basically, I mean, ultimately, this is going to give us every single entity that we have, right? Because obviously every single entity is going to have an ID component. And then we're going to loop through this, all of these ID components that we have and just create entities. And we can do that by basically, well, there's a few ways that we could do that. I mean, ultimately, at the end of the day, we're just trying to call new scene create entity with UUID, but clearly we need two things, a UUID and a name for that entity. So that's what we're going to pull out here. The UUID will just be e dot, well, I guess we'll just use, we won't make it in like a Hazel entity. Source scene registry get ID component dot ID. And sorry, we need the actual entity, and then we'll also get the const order, I guess, name, which will be the tag component. Right, so we have a const string here. So UUID and name, right? So what we've done here is we basically created all of these new entities. So for every entity that we had in the old scene, we've created a new entity in this new scene, right? Now, they are going to have the same ID, the same UUID. However, within entity, right? Within that library, the ID that they have is going to be different most likely, right? So what that means is that, again, like that's fine because we don't trust that anyway. That's just used as an indexing for a data structure, right? UUID is what we actually use to identify entities, and that's the way it should be. So the last thing that's going to be a problem here, which we might revisit later because we'll naturally see this pop up, is we need some way to actually know which entities, which of these entities that we've created here corresponds to which UUID. Now we could ask it to please give us all of the entities with ID components. Let's iterate through them and let's try and find, an entity with this ID, right? Why? Because we obviously have to give it components now. That's the next step. So we'll talk about how we can do that with a little bit less kind of finding by just using a map basically. But the next step is to copy components. Now the two components we don't need to copy, right, is ID component and a tag component. Why? Oh, well, yeah, ID and tag. Why? Because this is what we already copied them, right? So create entity with UUID obviously adds an ID component with that ID and a tag component with that name, right? It adds the transform component. However, we still have to copy the values from that transform component. So we'll have to do that here in a minute. But the point is that ID and tag should be intact. And now we just need to copy everything. So how do we do that? Well, I'm going to write this in a very simple, easy to understand way that we will probably change a bit later because I just want to introduce it kind of softly. But what we're going to do is we're going to write a function called copy component, and we're going to basically call it for every single component, right? It's going to be a templated function. Just trying to be a little bit relaxed here on the templates and stuff. So template type name T, I'll call this component actually. And then this is going to be called copy component. So how do we copy a component? Well, a few things has to happen here, right? So we need to basically look it up from the source registry, see what it is, and then copy it into the destination registry for a particular entity. And this is again where things get a little bit complicated because we can easily pass in these registries, right? So it's just going to be ent registry. So we'll do this. I guess I'll put the destination first, kind of like mem copy and stuff. So we'll have the destination registry, the source registry. But the problem is that whilst, we can copy the components if they exist, and we'll talk about that in a minute, we obviously need a little bit more information than just this is a component, right? Because a component has, the component is its data, but then we also need to kind of link that component to an entity because an entity has to own a component. But the problem is if we're arbitrarily copying components here, well, yeah, we have a bunch of entities in destination, we have a bunch of entities in source, but as far as ent is concerned, their IDs don't match, right? UUID is what we need to use to match them up, right? So how do we know which component belongs to which entity? And this is where it gets a little bit tricky. So ultimately though, let's start setting this up. We just want to establish a view, right, of the source registry for whatever component, thanks for that correction, for whatever component we're trying to copy. So in other words, in this case, it's transform component. I'm passing in the destination scene registry and the source scene registry. So I've got this transform component. That's what component is. I'm establishing a view of the transform components, which again should be laid out all together kind of in memory, right? And if that is the case, then obviously it's nice to iterate over all of them. It should be quite efficient. So then we'll go ahead and we'll just do auto E in view, right? But again, like what needs to happen here is I need some way now to, because I know the source registry entity is E, right? But I don't know where it should go into the destination. For which entity should I be copying this transform component into, right? That's what I don't know. But that's again where that UUID comes in. So if I just do source.get, right, it's going to be ID component for E, right? Then what I've done is I actually know what the UUID should be, right? That is the UUID of this source entity which contains a transform component. But what I need to do is somehow figure out where inside ent that ID component is for that new entity. This is getting very complicated. I know it's hard to explain. It really makes sense. I probably should just draw something, but I think you guys are hopefully getting the point. Maybe I'm over explaining this, but my point is that again, we've established the UUID of the source entity from the source registry that we're copying from. We just need to know where to put it into the destination. And we know that obviously the ID is going to be the same, but how do we communicate that to ent, right? Because ent is the thing that is actually going to store this. Like we need the ent ID, right? Which is ent entity. This is what we need so that we can add a component to it. But we don't have that, right? So this is where we're going to introduce a map so that we can actually map these ID components into that. Because the other option would be to basically set up a view, right? An ID view or something into the destination registry. So we could do like destination view ID component, right? And then obviously we could iterate through that. So that would be like DE, destination entity, ID view, and then see if DE, get, what would it be? ID view dot get ID component, DE, right? Dot ID equals this source ID, right? And if that's the case, then DE is where we add it. So we can do DE, in place, DE should be an entity, right? No, sorry, it's from the registry, obviously. So it'll be like DST dot in place, whatever we're copying, for, there's a nightmare, for this entity, right? And that's how we would basically, and we'd pass this along into the copy constructor. Like, well, we need to actually get the component as well, right? So we'd need to retrieve the component as well, like whatever this is. So that would be like auto component equals source.get component E. Why does it keep capitalizing it? Come on, go away. I've never actually done this before. So if I type in like transform component, which it doesn't even know, then I think it should be able to maybe, look, it doesn't even know. Do I have to do Hazel? Transform component? Does that work? Thanks, bro. Maybe that will help with IntelliSense. But anyway, and then you pass in a component. So hopefully this makes sense, right? This would work and this is fine, but we have this like extra level of like we get a nested for loop, we have to iterate through all the entities in our scene just to find it. Like that's really, really annoying considering we already have both the UUID and the entity kind of thing here. So what I'm gonna do instead, right, of doing it this way is I'm going to basically set up something, and this can be, I don't really care what this is. It could be unordered, it could be ordered. Doesn't really matter. I guess we'll put it into an unordered map because I don't think we've implemented the less than operator anyway, and we have the hash operator. So we'll do UUID and then entity, which is really just like a uint, right? But the point is what we have now is an ent map. And we're just gonna make it like on the stack over here. Like we're not gonna set it up as a member or anything like that, doesn't need to be. And then what we'll do is into copy component, we'll pass in this ent map, right? And then I'll grab the ent map like so. This can be a const. In fact, the source can be const as well, the source registry. And we'll call this ent map, right? And so what does this do? It avoids this entire search, right? Because instead of this, what we do is like we have the ID, right? It's over here. Let me just bring this out and try and be as clear as I can. Right? We have the source ID, right? Which is the same as the destination ID. So now all I have to do is basically just do entmap.at, right? UUID. And that gives me the actual entity like identifier. So ent ID. That's it, right? That's it. So this one kind of line avoids this entire kind of search here, which is obviously going to be very good for us. So, and that will only just grow when you're basically reducing like this kind of linear search with, just like a constant time lookup, right? So order n, I guess, versus order 1. So anyway, the point is this is a better way of doing things, and that's why we've done it that way. Had a pretty long day today, by the way, so if I'm a bit slow, I apologize. So yeah, that's basically it, right? And then we can actually get to the meat of this, which is copying the component. So we know which entity is kind of the destination receiving entity. This is the entity, this is the destination entity ID. I'll be really clear about that. Right? So the destination ent ID. So now what we can do is into the destination registry, now here's what I want to do. I want to do in place or replace. Why? Because it already has a transform component. So I want to replace it with this new transform component, right? Whereas for a lot of components, it won't be replacing. It'll just be adding. So for a camera component, that obviously wouldn't exist. So I'm actually creating it. So in place or replace is a good function for this. So what I want to do is do in place or replace, and then we're going to do whatever component it is that we're working on, right? Which is in our little example is a transform component. And then we're going to actually put in this component. Right? Oh, and of course we need the entity, which is destination entity ID, right? And again, what this will do is it forwards all the arguments into the actual, constructor. And of course, every one of our components has a copy constructor. Here it is. So that's what we're doing here. We're just using that copy constructor to basically copy it. Now, we could probably make this a little bit cleaner, but I'll leave it like this because I think it makes more sense. And then we basically have to do this for every component that we have. Now, as I said, I'm going to do this the kind of easier way. What we probably should do is establish some kind of component registry, so like a component type registry, right? Where we just have like all of the components that are components, and then we can like kind of, I don't know, const expr, statically compile time, iterate through that, and then call copy into component, write a template which expands that into every single component that we have, right? If someone wants to write that, by the way, then maybe like open a GitHub issue on the repository and just write like an implementation of that. I'd be happy to review it and accept it in the next episode. I'm doing it this way for now because first of all, I think it's just going to be a little bit more clear without just complicating the code so that people understand like the basic premise of how it works. And also because I'm not going to pretend I'm a template expert, and it's probably going to take me a little bit of time to actually write something like that. So, but if you want to, then that would be great, because we will do that eventually. Like I'll probably switch to that anyway. Okay, so let's take a look at all the components we have. So transform, sprite renderer. We don't have that many, so I'm not going to bother like, you know, kind of going through all of them. And that's why this is also okay. I think that actually might be it. Do we really only have 5? What do I have in my, oh yeah, native script, which I think is right under camera. I'm doing it in the same order as it appears over here. All right, so that's it. Now we've copied everything, and of course, I think that should be it. So we've copied the entities, we've created new entities, right? So create, let me just reorganize this. So create entities in new scene. And then of course, copy the components, right? Which is the actual data that makes up the entity. So that looks good to me. Hopefully I haven't introduced any bugs here. But yeah, that's actually pretty much it. That's all there is to making this new scene. We should now have a scene that is identical to our other scene, apart from maybe some different like entity IDs, like ent IDs. Very hard to distinguish between the word entity and then the library entity, because they're called the same thing. But anyway, you get the point. All right, great. So back over here, what does this mean? Well, I actually think it will just work, possibly. So let's, it's always scary. Let's try and compile this, run this, and we'll see what happens. Okay, so here is our physics 2D test scene. Let's hit play. Okay, we get a crash, that's okay. Yeah, one thing I should have done is probably an assert. Oh, well, actually that's a bit silly. So this map's obviously empty. So we need to actually add the stuff into the map. Can't believe I forgot that. So basically, again, once we have the destination entity, which we've created over here, right? Because what this does is it returns an entity. I'll call this new entity, right? A new entity is going to contain an ID, which I think if we just use it as a, so how do we get the handle out from it? Well, actually it has an implicit cast. So we can basically, we should be able to just do ent map. The UUID is UUID equals new entity, just like that. And we can obviously be a little bit more explicit about this if we want, but again, the type is just that, so it should be fine. Right, so there we go. We are putting that in, and of course, you know, you could cut that whole thing out if you wanted to and just do that, right? But I'll be a little bit more explicit as usual. Okay, great. So now, and again, you know, what we could do is, it's very unlikely for this to ever really happen, but since we are using at and not find, we could put in a little assert to make sure that ent map find was called UUID doesn't equal ent map end. Just to, like, you know, be like, this shouldn't happen. Hopefully it makes more sense kind of in the code, I guess. Asserts, by the way, they're not just, I think they're not just for like actual debugging and validation during runtime, like they usually are used for. They also make more sense in code, right? Because you're telling the programmer here that this should never happen. Pretty obvious, right? So they actually document the code pretty well as well. All right, so hit play. We got our play, hit stop, we've got our stop, right? So what we have achieved here is, again, we can hit play, we can do whatever we want with our scene, you know, and obviously what's gonna happen is when we hit stop, it's gonna reset. Pretty amazing stuff. Now, the last thing I wanna do today, actually, which I almost forgot about, is I just wanna be able to duplicate entities, right? So we have the ability now to copy components, right? And because we have the ability to copy components, we should also be able to kind of introduce this kind of duplicate function, which actually, I mean, copy component is a little bit different because this uses like an ent map and it's clearly made for scenes. But what I want to do is just write a function here called duplicate entity, entity. All right, and this is just going to duplicate it. So what do we need to do for duplicating an entity? Well, let's create a new entity. Now, obviously in this case, we actually do want to do create an entity without UUID, right? We wanted to generate a new ID for it because obviously we're creating a new entity. So the name is going to be, well, I guess we'll use the same name. So we can do entity get component, or is there just a get tag? No. Well, let's add that. That's kind of nice. So we have get UUID. So I'm also going to do a const std string get name, right? And then this is just going to return tag component tag. We should probably call them names because tags can be used for other things, but that way we can just do get name and everything looks good. And then finally, what I want to do is I actually want to create a function called copy component if exists, right? So this is going to be similar to this. It's just a bit different because this is within the same registry, right? So it's obviously way more kind of simple, but what we do need to know is the source entity and the destination entity. Right? So I'll call it copy component if it exists, because obviously if it doesn't exist, then we won't copy it, and you'll see how this is going to work. It's very, very, very simple. If the source entity has the component every time, then destination dot destination add. Now, the problem here is that, again, we want a bit of like that in place or replace thing. So what I'll do is I'll actually copy this and I'll call it, I guess, what should I call it? Probably like add or replace component, something like that. Add or replace component. So we don't need to assert this because it's fine if it already has it. And then we'll just do in place or replace. That's really the only difference. And then I guess we'll do this garbage as well. But that's it, right? And then this, again, for things like transform component, it will just overwrite it. But then for things that don't have it, right? Because I'm talking about the destination. Just because when we create the destination, obviously it's going to already have a transform component and that kind of stuff. But we'll do add or replace component. Visual Studio. And then, we'll have to do like source, I guess, get component. Just gonna copy this because otherwise it's gonna capitalize it. And I think that's it, right? So if the source has the component, we add it into the destination entity. And that's it. Again, this all happens within one registry, so clearly it's kind of different than what we had before. Now, all of the components, right, we'll do it the same way. Again, once we have the kind of component registry, we'll just iterate over it. But what we'll do is, let's do, so this is going to be copy component if this, and then we'll call it, I don't like this is okay, that's okay though. So destination is new entity, source is entity. Not the best naming as usual, but that's okay. All right, we'll go ahead and go through all of these as quickly as we can. And that's it, right? So we now should be able to duplicate entities. So if we go back over here, I'm going to make obviously a way for us to be able to do this through the editor. I'm just going to make it Control D. So we have on scene stop on. We'll just make a function called on duplicate entity. We should have like some kind of command thing maybe soon, but this is like really simple. This is just going to be like if I guess if M scene hierarchy panel get selected entity, if that's even like, if we've even got anything selected, then we'll do M editor scene. Now, this I guess should only happen if we're in edit mode, right? So if scene state doesn't equal edit, we'll just return. But otherwise, whoops, just close the file. But otherwise we'll just do editor scene, duplicate entity, and then it'll just be this. So I guess I'll do, I don't know, should we write code like this? Probably not. I don't know if that works on all compilers these days. We'll just do this. So yeah, and then we'll just basically just duplicate it. So how do we call this? Well, Control D as I mentioned. So if we go over here, we'll just add another one of these commands maybe. I don't know. Those are also commands. Scene commands maybe. I don't know. D, and then obviously if we hit just Control. I don't know if I like this whole on for this, but whatever. F5. So yeah, so now we should be able to duplicate entities, which is actually going to be, oh, errors everywhere. Never mind. So in place or replace, didn't seem to work out because I have parentheses in the wrong place. All right, loading in our physics scene. So this is actually, this duplicate entity, you might be like, why am I adding this? Because it makes it so much easier to make little levels, right? So all I have to do now, hopefully if this even worked, is if I hit Control D, it didn't work. This is just fun. So create entity with something to do with the tag, error characters. Okay, let's debug this. So what error? That was just an error. Entity.getName. Okay, so that didn't, oh. Well, so what if it doesn't have a name? But it has to have a name, right? Because if it doesn't have a name, then it has the name entity if it was created with an empty name. So it definitely should have a tag, right? So I wonder why. Wait, did I definitely had something selected. Yeah, I did. Get name. Get component or tag const string. Get tag component tag. That should be okay. Let's try and debug this a little bit. We'll see what the entity handle is if it lets us. So let's go back to duplicate entity. Oh, it's got an entity handle of 0. That's weird. So we didn't have anything selected? Handle 0. Then why did that pass that? Oh, because 0 isn't null. So I guess, so is that fine then? I guess it is fine. 0 is a valid ID. That's right. I keep thinking 0 is not valid, but this clearly didn't work. This is very strange. I still don't know why this is happening. The only thing I can think of is, because what happened is, so we retrieved the name here, but then we call create entity with ID, which adds another tag component. So it's possible that the location in memory has changed for the original tag, but that, like, I don't know. So what, I guess what we could try is, that's very annoying though, isn't it? We could try give it like a name that's, you know, been copied, but it's kind of annoying. So basically if we go back here, we do entity name like this. Let's see if that also doesn't work. Okay, so one thing I'm noticing, by the way, just as I open this, is that the scene hierarchy is blank. What? Is it? What? That's suspicious already. Why is the scene hierarchy panel blank? Oh, because the context gets set to active scene, which is nothing. Okay, so let's do this. We'll go to open scene. So if it had no context, then it couldn't have returned a correctly. So that entity never existed, I think, was the problem, because it never had a real scene. But no, but hang on. When we hit open though, we set it to be active scene. Oh, but this is before we do that. All right, so editor. We'll change this to be editor scene. And then the other thing I want to do is when we actually hit play, we should set it to not be the editor scene, right? So on scene play, we'll set the context to be this runtime scene, which is active scene. And then we'll do the same thing on stop, right? So that way, you know, if we are spawning entities while our game is running, we'll be able to see them pop up in the scene hierarchy panel. So I suspect that we probably, like, that makes sense now. Oh, well, that just crashed. I was gonna say that makes sense now. But I don't think we need let's see why that crashed, but I don't think we need the string and copying the string and stuff like that anymore. But what's going on here? On ImGui render doesn't work. Yeah, because context is null. So what happens? Can this just not deal with no scene? That's weird. Well, whatever. So basically, obviously we only want to do this if we have a context though. The way I'm shocked that this worked before. That's very weird. So if there's no context, then we'll just do a blank panel. Yeah, I don't know what was going on there. That's weird. I guess when you create it, you're forced to give it a context immediately. Oh, but where's the properties panel? Whoops. So the properties panel happens here. So, and that's only if we've got selection context. So actually that doesn't need to, it's just this panel. If there's nothing to display, then there's nothing to display. And again, it will have if it's an empty scene, it'll just have an empty context. Like it won't be empty, meaning it's null. It'll just be a blank scene. Yeah, this whole engine is, okay. That must have just been me. Yeah, because end is here. Oh, begin. Yeah, whoops. We still want to draw the actual panel, just not the contents inside it. For the scene hierarchy panel. Lots of little stuff here happening. But okay, so let's try and load that scene. Okay, we actually have that stuff now. So now if I hit Control D, yeah, that seems to have worked. Let's go back and fix our code so that it's not doing this. So that should be okay, right? We should be able to just get the reference of it because we don't want to copy the string because it should still remain where it is, I guess. And then if I hit Control D, oh, it crashed. This is super interesting. What I want to do is let's just grab this again. Let's put a breakpoint in. And I want to see what's actually happening here because it looks like, because I want to see what happens when we hit Control D. Let's see what our name is. So our name is floor. That looks like it's correct. We're on duplicate entity. But then once we add this tag component, aha, our name has changed. Error reading characters of string, right? So I guess what's happened is it has in fact been moved in memory and now the reference is invalid, right? So yeah, that's a bit unfortunate, I guess. But that's the way it is. So we will have to actually preserve this somehow. You could also make it so that this doesn't like return a const reference, right? Because I guess it is kind of dodgy. This will always give you a reference if you don't copy it. So you could always do that. But I guess for name, like if you wanted to, you could change it to return by value like that. But again, me personally, I think that if you know what you're doing, it's better to just have it return by reference so that if in fact it wasn't a scenario in which we're actually playing with the registry, and potentially moving things, then it would actually, it would still remain a reference. But this way, if you actually want to copy it, that's very bright. But this way, if you actually want to copy it, then you can, of course, write code like this, which will in fact copy it because you're making a copy of it. So now I guess this should work. Yeah, that was unexpected. I'm pretty sure I wrote the code with the const reference and with everything in the live stream. And it was totally fine. So it might have just been a case of the registry didn't need to resize. Yeah, weird. I don't know. Or maybe I'm just missing something now. No clue. But anyway, let's get rid of all of this stuff. Control D. Yep, seems to have worked. Anyway, so as I was saying, the benefit of Control D and all of that stuff is that obviously now we can easily set up this scene to be way more interesting, right? So if I come over here, maybe let's set this up here. We'll duplicate this. You can see how we can start to create a pretty interesting world, right, of this thing moving down pretty easily, right? And if we hit play, then we can see that's rolling. Now we can be extra cool with this, right? What I can do is I can actually make my camera, we could also give the camera a rigid body and a box collider and make it dynamic. And now, oof, that's strange. We probably should, the problem if it's done is it'll start bumping into stuff itself. So maybe, I wonder why the size is 0 by default though. Shouldn't that not be 0? Shouldn't it be like 0.5? Why is it 0? I didn't know box colliders had a size of 0. Yeah, it should have a size of 0.5. Is it because it's duplicating it from somewhere? No, I just added the component. That's very strange. Oh, I think I know what this is. So let me just hit like Control S here. Oh, Control S doesn't work. RIP. Oh my goodness me. Okay, whatever. I didn't lose that much work, but Control S. Should fix it right now, but we're out of time. Anyway, let me quickly see. I think I saw a comment about this. Yeah, we're just displaying the offset twice. So this is actually size. Whoops, not in Russian. So yeah, so I think I was, yeah, it was like the actual values are fine. It's just it was being displayed incorrectly. I can't believe that. Stupid Control S. Anyway, all right. So take 3. Let's do something exciting now. Let's move this around. I hate not having Control S. We should do it very soon. Okay, and if we hit play, then that's great, but we can't see anything. So let's go to the camera. Let's add a box collider, except we can make it quite small, 0.1, 0.1 or something. And then we'll add a rigid, but it doesn't matter where it is, like the fact that the camera's far away, because of course it's only 2D physics. So we'll make it dynamic, and now you can see we kind of follow it, right? Kind of. Now, one thing we could also do is actually fix the rotation. That'll probably make it a bit easier. But yeah, you can see how we kind of more or less follow this, but the camera actually has its own physics associated with it, which is pretty cool. And we can be really cool and add like some restitution as well, so that we're a little bit bouncy, and you can see how fun that is, right? So you can see that we can kind of already start making some kind of game here. And obviously the great thing is when we hit reset, everything resets and everything's fine. Let's maybe make this dynamic. That'll be interesting. Now everything kind of falls. Oh, that's it. It's kind of boring. Anyway, yeah. So I think what I'm going to do right now, actually, just because, you know what, I'm just going to do it. Episode's long anyway. Let's add Control S. So back to editor layer. What we'll do is we'll do save scene as. I'll just make a save scene, right? That's just going to save the current scene. Now, for that to happen, we need to know what the current scene is, right? So active scene, I don't know if this has a file path. I don't think it does, because it doesn't know anything about files. So what we'll do is we'll just make an std file system path current scene path, or we'll just say editor scene path, right? When we open scene, right, if it works out and everything's fine, then this path, right, if we deserialize, we'll just set the editor scene path to be the path, right? And what this means is that when we want to save the scene, so save scene, let's go ahead and make that happen. When we want to save the scene, we'll just use that. So if this is like a real path, because we might not even have something open, and it also might not be, I guess it might not have been made yet. So is there a way we can, yeah, let's check if it's not empty. So if it's not empty, then we'll just do this basically, right? So, well, again, this is a bit, okay, we might have to change this a bit, but yeah, ultimately this is what we're trying to do. And this unfortunately takes a string. So for now we won't change it, but that's really all that needs to happen. If the path isn't empty, we do that, right? Now, if we hit new scene, this is a big one. You probably want to make sure that you actually like reset this, right, to something else. I don't know if you can just set it to empty. I guess it doesn't like that. std file system path. Can I just not set a path? I guess I can do that. Because we obviously don't want, otherwise we'll hit Control S and we'll overwrite our old scene with this new scene that is empty. And that's a great way to lose work. So make sure you don't do that. Make sure you kind of keep up to date with that. And then obviously every time we open a scene, when we do save scene as, we also want to change that, right? So we'll do save scene as, and then we'll do, what is it? Editor scene path equals file path. So that's what we've saved it into. So we basically need to update the path, and we need to kind of keep track of that. That's important. So Control S, if it's shift, so let's just do if control, and then if shift, we'll do save scene as, else, well, if it's nothing, we'll just do save scene. Okay, and that's pretty much it. Now, the only thing that I don't like about this is that we kind of have this kind of code duplication here, which can make it annoying. I mean, I guess here we don't need to update it, but what you could do is call save scene from here, but this is specifically not save scene. Maybe we should make a serialized scene function. Probably. Let's maybe do that. So we have save scene, but let's make a serialize scene. And serialized scene is going to basically take in a scene to serialize, and then a path. So this will be like the ultra kind of correct way of doing this. So what we'll do is basically, all I think it needs to do is this. So we basically grab the scene, and then we serialize it to this path. And I think that's it. Doesn't ask any questions, doesn't care. You just do it, right? And so that's good because obviously we can call that and it's a little bit more clear as to what we're actually doing. This takes in the file path. And then here we do edit a scene path. Okay, cool. That looks pretty good to me. So let's go ahead and hit F5, test that out. I think that's the only two things that save anyway, so I think we should be good. And I made the control, I actually implemented Control S, I think. If it's empty, it won't do anything, but it should bring up, it should probably bring up the save as thing, right? So if we move, well, let's just duplicate this basically. So I'll duplicate this, put it somewhere else, hit Control S, and then I don't know, load something else, load it back. There you go. Okay, so it has in fact serialized it. And then I guess the final thing I'll do to tidy this up a little bit is, yeah, we can just say, I guess, else save scene as, right? You could also make that happen inside that switch kind of on event function. That's also fine. This is programming, lots of ways to do the same thing. We could talk for hours about the benefits. But yeah, the good thing is that if I start a new scene and then hit Control S, it's gonna bring up that save as dialog box, which is exactly what we want. Anyway, thank you guys for watching this video. I hope you enjoyed it. If you did, please don't forget to hit the like button. You can show your support as well as get access to Hazel 3D, the big version of Hazel. I'll probably keep calling it everything, even though we've agreed that this game engine series is Hazel 2D and that is normal Hazel. But anyway, Patreon.com/Cherno, best way to help support the series, get access to all of the lovely source code, and of course you'll be supporting the development of the series, as I mentioned about 500 times. A huge thank you to everyone who does do that. That is in fact why I am able to do this, so thank you. I think we're pretty much caught up with like the live streams now. The live stream that I did last week. So tomorrow, which is Thursday, I will be live streaming on twitch.tv/Cherno, as I do every Thursday, working on the next episode, whatever that may be of this. And then we'll probably have it come out like maybe even tomorrow night. We'll see. But anyway, thank you guys for watching. I'll see you next time. Goodbye.